All right, I just finished some floppy disk testing, and I'm just going to quickly share the results. So here is my method. I take Greaseweazle and a Commodore Amiga floppy disk drive, and I'm testing double density disks. And so what I do is I go in here and I run FluxEngine, and I put the disk in and I run it through 4 different types of tests. And those tests are Macintosh 800K double-sided, Amiga 880K double-sided, Commodore 64 1581 double-sided, and MS-DOS 720K double-sided, and they're all double density. And the results, so I made these custom labels for it right here. And so I just go through, run the test on the computer, mark it on the label, and here are the results. So you can actually see the distribution where these disks have all passed all 4 tests, no problem. I'm just writing a random disk image with some lorem ipsum text in a text file, so nothing particularly interesting. This one had at least 1 format fail, but 3 others pass. These are 2 failures, these are 3 failures, and these are all formats failed. So you can see here, I've got my initials, I got December 2025, everything passed. And you can see here, this is where 1 format passed. Now, the Mac and Amiga format are very forgiving. In my experience, they rarely fail. Whereas if it's going to fail, it tends to be these last 2, and that's because the density of the data recorded to the inner ring of the disk is the highest, and the magnetic media obviously is smaller. So that's why this distance, right, there's less magnetic media versus, you know, this distance. Like this is maybe twice as long. I mean, I'm not doing some calculus in my head, but I think this is twice as long a circumference as this, which means you've got twice as much magnetic media to store the same amount of information unless you change it. So what we see is that as we get failures, we get less and less and less. So I don't know what the numbers are. I haven't counted them yet, but there's almost 20 here. There's, I think, just under 10 here. This looks like 4, 2, and then 1. So there's our distribution, if you will. But you can see when I grab these failures, because of the way I've done these labels, now we can see what's going on. So right here, see, it's the 1581 seems to be the least forgiving and the most failures. And I suspect it's because it's similar in format to the MS-DOS, but has a higher density of information. So when you get to those inner rings, that's where you see the failures. And you can see most of these are failing with that format. But then weirdly, this one failed on the Mac format. The Mac format slows the disk down, so there's less information on that inner ring because there's less density, and more on the outer ring where there's a higher density. So usually this is the most forgiving format. So that tells me maybe I should clean the drive again. I try to clean them before I do a series of tests like this, but I don't know. There might be a specific hole and it's only being caught by this. Like, I don't know. So that's worth investigating. But they're all failing on that 1581. So that's a good test. If it formats for a 1581 as a quick test, it's probably going to work in other things. But if I move these off to the side, we can look at what fails too. So we can go here, and what you see is most of the time you get a pattern like this. A pattern like this, where these formats, again, have a higher density on the inner ring than these formats. So you see these failures. So for 3 of these disks, that's the pattern that we see. But for this disk, it failed these 2 and then passed these 2. Again, this is weird. This tells me that maybe the drive needed to be cleaned. Maybe there's some crud on the heads because I had already finished several disks at that point. I figure every 20 discs if you're really hammering them like this, because again, I'm hitting each disc 4 times and I'm hitting the entire surface. So if there's mold that can accumulate on the head, 4 times 20, that's 100 passes, for both heads. Boom, you might get some buildup. So, but that's an anomaly. Seeing those 2 formats fail and the other ones pass is very unusual. So this is the common failure, and this is the common failure, and you see that, which is very interesting. So the denser the format, the more likely it is to fail. So again, 4, and then the densest one fails, and then the 2 densest ones fail. And then when you get here, obviously these discs either had a manufacturing defect or they just are too old, too moldy, something like that. So if we look here, everything but the Amiga fails. And I've often found other discs that look like that, that have that failure mode where it's only the Amiga that passes. So there's something, maybe it's an error correction, the nature of the error correction on the Amiga format, or the density of it. I'm not sure, but I've seen that before. Here, everything but MS-DOS fails. Again, this tells me that there's probably damage, and it's probably on the outer rings. And that's why we were getting these weird... And here, everything failed. There was something wrong, that there's probably a hole on the disc or something. I'd have to look into it. But I find this very interesting. And here is a graph of the results in physical floppy disks. So there you go. And the fact of the matter is, at this point, floppy disks are old enough that you could, now these were used, but you could buy a brand new box of floppy disks. And just because the box is sealed doesn't mean that they're fine, because it, like, pretend this box here wasn't a disk cleaner box, but it had floppy disks inside. So if you imagine that this is sealed up and covered in plastic, right? If there's no package of silica gel inside, then any moisture that was captured in the box at the time of manufacturing is just going to have 10, 20, 30, 40 years of sitting around in that box with nowhere to go. And eventually, if there is some mold spores inside there, you get a little bit of mold, a little bit of moisture, nowhere for it to go. Conditions get warm enough, boom, you've got mold. So discs that are brand new in box, I still do this testing with, because you never know what's going on. You never know how much damage is taking place inside the boxes. So there you go. I hope that was helpful, and rock on.